This recording, I will show you how to evaluate the limit of theta goes to 0 plus of sine of square root 2 theta over square root theta. Now, if you try to let theta goes to 0, you'll find that sine of square root 2 theta will goes to sine of square root of 0, and sine of 0 is 0, so this will be 0. So the numerator, we know that it will put 0. Now, sure enough, square root of theta, when you let theta goes to 0, it all goes to square root of 0, and this is also 0. And you have a case of numerator equals 0, denominator 0. And what is this? Another thing I want to mention over here is this has a limit of goes to 0 plus. Now 0 plus means limit to the right of 0. So this is a one-sided limit. And it means that theta approach 0 and theta is always greater than 0 now. Why do we need this theta greater than 0? Because there is a square root function there, and we know that we cannot take square root of negative number. So now, how to evaluate this? We are going to make reference to Howard Anton text, chapter 1.1. There is one example, limit of sine x over x when x approaching 0, and this limit is equal to 1. How do we get this? To get this by forming a table. We let x changing from 1, 1, 0, 0 0.9, 0 0.8, all the way down getting towards 0. And then you construct a table of sine x over x. You find the value goes from 0.84147, 0.87036, all the way increase, and then you get 0.9998, and you show that, so you can guess as x approaching 0, the value of sine x over x approaching 1. That's why you have limit of x goes to 0, sine x over x approaching 1. And notice that when you do the calculation, your x is in radian mode. We are going to use this result to help us do our calculation. So the result we have is limit of theta goes to 0, sine theta over theta is 1 based on Howard Anton. So now let's do the calculation. I'm going to do some adjustment. This is the same as a limit of theta goes to 0 plus sine of square root 2 theta. I'm going to make the adjustment so that I have square root 2 theta on the denominator. However, this is not the same as the original expression, so I must be able to cancel away the square root 2. So I multiply by 1 over square root 2. Now this is the same as limit of theta goes to 0 plus square root 2 times sine square root 2 theta over square root 2 theta. Now you can take out the square root 2 and take limit of theta goes to 0 plus sine square root of 2 theta over square root 2 theta. Using the result from Howard Anton that limit of sine theta over theta when theta goes to 0 is 1, so I have sine of square root 2 theta over square root 2 theta. Notice the angle are the same. When theta goes to 0 plus, this is going to be 1. So you have square root 2 times 1, and the answer will be square root 2.